All right. So, um, along with the moving down to the basement, it also means I only have one monitor attached to the desktop right now, and because the desktop doesn't have a built-in monitor, so I can't actually see it. Zilby, you are not dying. You are just begging to get into a room, and you know it. Here, have a have a ball. Zilby, Zilby. There. Maybe he'll be happy with that. Okay, so on Friday after work, I loaded up the code base, just sort of take a look, see what's going on, see how everything looks, and I decided to do maybe just a tiny bit of coding, and next thing I know, I've refactored a whole bunch of things, and then we're here. So I was actually trying to figure out how I can put all the scenes into a hash map. Um, and then what I discovered is that hash maps, or at least I don't know how to do it properly. I can't do box dine the scene, which is the trait that all of these scenes have. It doesn't like that. So instead, I think what we're gonna do is we're gonna store all the scenes individually like we were before, but I'm gonna um, remove the scene trait like completely. I don't think we need it at all. So, for example, we can remove this. We want we have our starting scene, main scene, pause scene, end scene. So we're gonna bring these back again and store them exactly as they are. So instead of scenes, we'll do starting scene is a starting scene start scene. And then we have a main scene. Main scene, we have a pause scene, which I still am not convinced that we need a scene separately. And then what's last? End scene. End scene. And then we already have them created here, so instead of scenes, we'll just go ahead and load them up. So that will be starting scene, main scene, pause scene, end scene. Okay, then down here, let's see, this should be, oh, right. One of the reasons that I was doing this is because I was updating how the main scene works with the pit and going between pages. And I wanted to, when we go between pages, tell images to reload the trees. Unfortunately, I don't have if I'm gonna bring in a mutable reference to images, I need to bring it to everything, and that's the reason why I was deciding. Well, if I'm gonna do this, I want to just have it be like one time that I have to write this, which would be that box dine scene. But unfortunately, that didn't work for us. So instead, I'm thinking we're going to just completely remove this hub trait scene. So you get to go away completely. Stop. And you see here this images that I added in that I haven't added to the rest of it. Okay, so you go away, and then for each of these, we're going to take these functions and move them just up in here. So now they'll just be on their own, and also this entire thing where they're taking in all this stuff that they don't need, that gets to go away now, because they don't have to care about any of this. Okay, so end scene, you're happy except you need to go away. Then main scene, and then you're basic. Okay, I don't need any of you. Okay, then main scene is going to be very, very similar. We're going to take the draw and update functions, move them here. Don't implement scene for scene. Don't bring in scene like that. And no more errors. Now everything here should be fine because the update is what we really care about. Now we're bringing in context that we don't need, and active scene. So, we're probably gonna eventually need these to at least move between the scenes. Let's see, mod is fine. Okay, pause scene. You get the same behavior. And remove you. And finally start scene. Okay, that makes you happy. And then in the main library, now we're still gonna have this match, but now when we call the update function, it's gonna be a lot simpler. So in starting scene update, all it cares about is starting scene update. Found 5 arguments. Okay, so after. I feel like you're not. Starting scene update. Oh, you do take all these things in, but you don't need to. So. You. Just remove everything you don't need, and that's going to be these two. So command and active scene. So you now are. Command, not the button pressed. Let's just reset you here. Okay, so for update, we need the command. That's this button pressed, which is the option command. Okay, so let's just rename you to command. And then the active scene. So I think that's so it's immutable reference to self.active scene. And update is private, right? So we have to make you all. See, and start scene, your pub, and your pub, and we don't need you right now. Okay, so that makes you happy. Next, let's go to main scene. So what do you care about? You're going to be public. You don't need a context, and you don't need the active scene. We'll just bring that in when we need to. And we need all of you, so you're fine. Okay, so active scene, we need a command. We need the config. That's going to be a reference to self.config. Images. This is a mutable reference to self.images. And then we don't need you at all. Okay, pause scene. We don't need any of you because we haven't done anything with you yet. And it's the same thing with you. Okay, so pause scene. You're not giving me updates. Let's reset you. Actually, you don't take anything at all, do you? And then end scene. Okay, you're empty there, and you just take into context for draw. So then you are that. Okay, so then this is happy, and it's gotten a lot less complicated here. We're only going to be passing the things in that it needs. I mean, what a crazy thought. Okay, so draw is going to be the same thing here. So self dot starting screen dot draw. What do you need? You need just the context. So that's all starting screen needs. For main scene draw, it needs context, config, and images. So context, config, images, you're fine. For pause scene, you need just the context. For the end scene, you need just the context. Okay, and let's see, no more errors there. When we're testing, creating the game state. Okay, so .scenes, .length, .for. So we can't really test that anymore. I suppose what we can test is that the active scene is start. And you need to implement a debug and probably partial equal. Oh, and you already do. Okay, so you just need a debug. So you're happy there. And up here, and bring in scene if it doesn't exist. And then scenes, well, we can't create you because that entire experiment did not work out. All right, so no more errors here. So now I can go on to the rest of the things that I was trying to show you, or what I did. So if we go back into the main scene, which is what we've been sort of working on, we were adding in pits, and we were trying to figure out how to draw everything properly. So where was that? That was in our game objects. Well, I've basically refactored out main scene in game objects. So instead of game objects being a vector of a game object, I created a struct game objects that's in here, I believe. Yeah, so here's game objects, and it's really just a wrapper around a vector that holds a game object. But by doing this, I can now have functions off of game objects for basically pushing into this array, getting the first by type, so querying for the game objects, and then running update on all of them. So basically abstracting out a lot of functions from the main scene into here. I've also created builders inside of this folder, and these are very basic. These are the same functions that we had inside of the main scene previously for building, the background. That all happens here now. And so that means that our main scene should be a lot simpler. Where's my main scene? There you are. When I create things, I can just say, hey, create the player. I'm still I didn't change how it works in a way for me to be able to avoid this expect. I think that's something that would be good to do, is not return a game result, but rather maybe a more traditional error that would allow me to question mark this. Right now I'm just creating a pit as out of test, and then we can just push this into our game objects using our own push method, which adds it to the, it's just it uses push behind the scenes. So we can implement shift, we can implement whatever whatever methods we want, and if vector doesn't give it to us by default, we'll get it. We'll be able to add that in for us. Actually, I don't think. Oh, kitty cat walked in, stood on her little play area, and then jumped off. So no need to turn on the cat cam then. That's a closet. There's nothing for you in there. All right, so that's basically what I did on Friday night, and so that gives us a good place to be able to implement this pit when we're in a map object, or when we're on the map. I want to say scene, but it's incorrect because I'm already using scene for like start and the main scene. Sort of like the screen maybe might be best. Take a look at how that looks. Almost. He almost hung out with us. Oh, Zilby, you can't go in there. That's not for cats. Okay, so what I was thinking for implementing the pits, and we did implement this one live on stream, our cargo.json. This is basically what everything looks like. We have pit here, and then I have another map entry that's blank, so we can move to the right, and we should get absolutely nothing there. Right now, if I run this, we're going to see a pit in both screens. So pit 1, that's appropriate. I move to the right, and we see another pit. So what I want to do is make it so that when we go to the right, it resets, removes all the elements, and then checks to see which ones to add in again. And I'm thinking that that's how we can like set up the initial thing too. And that's going to happen inside of, well, main scene is going to call it. So I'm thinking that we're not going to necessarily do this here. We already have game objects, so we can run methods on it. I think on game objects, what we can do is pass it in what the index that we're in, or like pass it in what the elements that we need. So maybe like clear all the map elements and then put in the map elements that we need. Maybe we can have like a function here to do that. Oh, a function to change screen. I think that would work out well. So let's see here. So if I don't know if I can do this as a CI. No, I can't, because if I need a main screen. So this is gonna be test changing screens. We're gonna need all of this in order to just get to the main scene. Once we have this, I want to be able to call a function on that. Now, I suppose we probably don't need to write the test here, because this is really just going to be calling functions off of our game objects struct. So I probably don't need this here. Let me start writing this, and we'll figure out what it's going to look like. So this is going to be a private function that we're going to call to change screen. I don't know if we're going to need to return anything or not. The first thing that we're going to want to do is strip out and remove all of the game elements. Okay, well, we can do that inside of game objects. And that can be a function in here. So if I have two, okay, so we can write a test for this, and then we'll write our function inside of here. Now I don't think, can we do this as, we might be able to do this as CI test. So CI test, remove, let's see, remove game elements. And I think, where's our enum for the type of game object? Under game object types, I moved this out into its own file. So feature, that's what we care about. So it's not elements, it's features. So I want to create a brand new game objects, and I want to throw two things into them. It looks like I can do that with just the config. So I can add in a player. We can put in, okay, so we can add in a player, and then we can create the pit. So game objects dot push player. We're also going to want to do a pit. Do I have a pit? Oh, I don't. Okay, so we need to create our first feature in order to add that in. Okay, so before that even happens, we need to come to builders, create a new file, and this will be pit.rs. And this is pit1.rs. So the way this is working is it's just a function that we can call that will create a pit for us. So if I have a, oh, you're working today for test section. That's nice. Okay, so let's do CI test create pit one. So we're gonna do let one equals one. And I'm not exactly sure what I need to take in right now, and but we do know that we're going to return a result, because it's going to be, we're going to use the object builder, the game object builder. So this is going to be object. No, you don't know what to take in. Oh, right. Before I do this, I have to mod this. Then this works. There you go. Okay. Object builder, and then this is going to be the game builder error. You are not returning you, actually. I'm just going to do an unwrap. Okay, so I want to get this out right now. It's going to be fine. Then here, we'll start creating this. So you are result object builder error. Okay, so we'll do in the end. Okay, then you're happy. Now, if I want to create a pit, what's one of the big things about their pit? We know we not want to have like the location of this, and we know that it's going to have this game object, so we can start having some asserts here. So assert equal 1 dot. So we should have a location dot x, and we know that we want this to be in the center of the screen. So to calculate this, you need to be, well, we're going to need to give it the config, so we'll calculate that. Config equals reference to config load JSON. We know we're going to have to pass you in. And you're going to be config dot resolution x divided by 2.0. So you're right in the center. Okay, so then we know you. We then need to start actually building this out. Game object. Builder, new. Location, to new. All right, for the x, that's going to be the config.resolution x divided by 2.0. So right in the center of the screen. We can also just say 500.0 for the y, and then .build. And we need to put it in. Okay. Now you are still upset. Strict comparison. So we need to fix that. Could be compare. There we go. Then, what am I doing here? Okay, I can run this test and it should fail because it should crash on this create build here. My type not set. Yeah, so okay, the type is not set. So we need to test that too. So assert equal pit1 dot my type. You should be a feature. Okay, so with type, name object types, feature. Okay, so you passed. Perfect. Then we can start adding in the rest of these tests. Okay, so assert equal 1.location.y. We need this to be in the center of the surface. So we're gonna have to do a little bit of calculations here. So this is gonna be config dot resolution y. So bottom of the screen minus the config dot bedrock height. Yes, config dot this is gonna be the cave height. Then the ground height. Then the surface height divided by 2.0. So yeah, you failed because it should be 740, but we got 500. So then, to fix that, we just do this exact same math here. And I can actually just pull this in. And perfect. Okay. So that gives us the y location for this. We also need we also know that it needs a width, but we can take a look at what the next thing is. One dot. Okay, we have location. We have my type. We know we're gonna have to have a width. So width is config dot hit width. So you failed because you didn't. It has 0 as a default, and it's supposed to have 75. Okay, so width, it's going to be config dot width. And you're happy again. Perfect. So standard test-driven development here. Write the test, make it pass, make it fail. Write the test, make it pass. So assert equal 1 dot. Okay, so we did width. Now, something I notice here is we don't have the ability to do a height, do we? But our pit has a height. So I think this might be good to add in a height to our pit, so we can figure out how we want to. Well, we need that to be able to draw it out. So that is, we have to add that in. So we need to insert equal hit one dot height is going to be config dot hit height. Unfortunately, we can't add that in here because I don't think there is a height on here. Yeah. All right. Well, that's next. We need to go add that in. So in our builders, so game object, we have the game object builder here. So we can add in height here in F32. We can give that a default of 0.0. With height, mute self, height is an F32, return self, height equals height, and return self. Okay, so that should make you happy. Now also adding this in, we can give ourselves a height equals like 50.0. And then we can assert equal player dot height is then you're going to fail because game object doesn't have a height. Now No method named height found in here. I swear. Oh, with height. So that makes you happy. Now all that's happy is that game object doesn't have that. So let's add you in. I don't know if this needs to be public or not. I'm going to move this up to width because it kind of makes sense for them to be together. And then I think that's all we need there. Oh, the build. The build function needs to now height self dot. Okay, so then you're all happy here, which means we can come back to hit 1. It's private. Okay, so we do need to make that public. Then you're happy, so we should be able to run you. You failed because our height is 0, but our height should be 130. So then we'll add that in here. All right, it worked. Let's see. Is there anything else we need to care about? No, I don't think so. I think we got it all. Okay, so that gives us everything we need here. We do need a draw system for a pit. And I think we have a single pit draw system here, so we do need to add that in. So draw system is box new single pit draw system new. And you don't really care about anything else. I don't think we need a life system or anything else. We can double check here. So draw system, height, life system, location. Location. Yeah, that should be fine. Okay, so that allows us to create this pit, so we can come back to main scene. Thank you, Zilby. That was the best. Oh, you found the cat cam. Let me see if I can position that. No? Maybe? Cat cam on. Sort of. He keeps on moving. Okay, so we're back to our main scene. And we need to remove all the game elements from the main scene. Remember that this is features from the main scene, which means that we're back to our game objects. We're working on this test here. So we want to create a pit. Create pit 1. Pass it in a reference to the config. Unwrap that. Okay, so we have a pit. We have a player. We push the player in. push the pit in. Then we want to assert that we have 2 items in here. And assert like the first item is type player. So I guess we can do is assert equal game objects dot length is 2. So that should pass. It does. Okay, we have 2 objects in there. We should assert that we should then run our function, and then so that's going to be game objects dot remove features, and then we're going to, after that, assert that the length is 1 and that the only thing left is type player. Let's go ahead and implement this. So we know that we need immutable reference to self, but I don't really think I don't necessarily know if we need to care about anything else because we're just removing these features. So what I want to do is probably use the retain. So we're going to do self.objects is equal to self.objects.retain. This, it keeps everything that returns true. So object, we want to return true if the game object dot my type is equal to game object types. It's actually opposite, right? So not equal to that. And retain, what do you return? You return a, you don't return anything. Oh, do you mutate in place? So I just want to do that. So then, after we run this, we should then be able to assert equal at game objects dot objects dot length is 1 now, and also that the type of that game object is a player. So assert equal game objects dot objects position 0 that my type is game object types player. All right. Okay, so that removes it. So we can now run this. Now is a public function, right? It is. Okay, so we can come back to main scene. And in change scene, the first thing that we're going to do is self dot game objects dot remove features. So that will remove all the features. We can then call this change scene right here. So now I can't do self.change scene because we're creating the main scene here. So I think actually this might make more sense to create the main scene here. We're going to return it here. have you be mutable. And then that means we can do main scene dot change screen. And so it'll be aware of what screen it's on. And that will tell all this to remove all the features. So if we run this, even though we added in the pit here, we should not have the pit displayed for us on that first screen. Yeah, okay, perfect. So then we've removed all the features, and now I want to check to see what features we're supposed to have, and then create them and add them in. And we have in the config, we have a list of the features. We have a vector of those features. So that means we need the config down here. It means up here we need to pass that in. Okay, so I need to pass in the config. We've removed all the features. I need to now loop through all of the map. I guess loop through the map. So it's gonna be config.map. You are a vector of map feature. Specifically, you're a vector of vectors. So config.map of position self dot current screen. So figure out what the current screen is, and then we're going to iter. Then we can for each this. This is going to be a map feature. For each of these map features, I now want to create the map feature. So this will be like this should probably be a match. So match the map feature. So this is a reference to map feature. I wonder if we should dereference this. Map feature. Is map feature not available to us? It's a pub. Okay, so it's public, so I have access to it. Map feature hit 1. I think this is going to yell at us. Okay, so if it's a pit 1, then I want to add a pit to the game. What would that look like? It would be up here. We want to then create our pit. And then we want to insert that in here. So this would be self.gameObjects. Okay, so what are you? Failed to resolve. No code actions. Can't bring you in. I should be able to get there from here. Okay, so map feature. So in map, we have this enum map feature. That's in the config. so we can see. Oh, we need to hub this. Then we can bring that in. Okay, perfect. And you're saying, okay, non-exhaustive patterns here. We can fix that. Fill your match arms. Those won't do anything right this second, and that's fine. Okay, and that pushes that in. Okay. Okay, so then we should have a pit again now. Let's try it. All right, perfect. We have a pit again. Now, when I move to the next screen, we still have a pit. Oh, and it's drawing. It's okay. So it's drawing in front of the player. So that's also a problem. We can fix that by switching this to a shift, which is to put it in front of the vector. Now, is it actually a shift? In JavaScript, it's called shift. To insert something at the front of the vector and shift all the elements down by one. But I kind of wonder, what about? Do I have the documentation up here? I don't. Oh, I have. So somebody shared this cheat sheet with me. I wonder if we can use this. This, in case you're curious. That's the URL for it. So probably, it's not really data structures. I need vectors. Oh, it has like all of these here. So if I search this for back 21 matches. So I want to look at the different. You're just stuck here. Oh, and then you're back at the end. Okay, so you're not really all that helpful. Oh, standard rest. Here's my. Okay, so I want vec, and I want to see what do we have that looks like we can insert into the beginning. There's inserts an element at position index, shifting all elements after it to the right. So we could do an insert like that. Push appends to the back of the collection. And I think that's an important thing. Whoa, wait, what happened? I wasn't looking at. Hello, everyone. I need to check what happened here. I don't see anything in here. 40K viewers raid. What? Wow, 40K viewers. That's the most I've ever had. Welcome everybody. My dashboard isn't even showing that. That's pretty crazy. Welcome everybody for that. We are I can't even see who rated me. I need to refresh you. No, that's not even working. I like the fact that I can now refresh and the chat actually still works. Well, anyways, I can't tell who rated me. I can't tell any of that. I don't know if maybe like the dashboard's broken. Welcome everybody. Welcome, welcome, welcome. How was your stream? And how's everybody doing? I am building a Pitfall style clone from the old Atari 2600, which is going to be a Christmas gift for my father. I'm going to build a console for him using a Raspberry Pi and ship that to him since I can't go and visit him in person this year. So that's what we're doing. We're building it in Rust and GGEZ as our language of choices. Um, and my chat in my other window, I have it on my phone too, and that's I think broken too because I can't. Nothing's updating, so that's wonderful. Sorry about not being able to like answer for anything else. I just can't see what's going on anymore. So that's lots of fun. Let me go ahead and show you what the game looks like. Oh, we have an error. We have to fix this. I will put this as a push again. So save you and cargo run. So I'm running this with a controller on my end, and I bought these nice sort of Nintendo style controllers because they're nice and simple that my dad will be able to understand. And this is what the game so far of what we've got. We got our player, we can move around. The pit is coming in front of the player, so I need to find the index of the player and insert one behind him. And then we can move around to the other screen. And once we do that, I need to remove the pit too. So that's what we're working on right now, is adding the pit in so that we can also fall through the pit into the caves down here. Last time we got basically all of this down to just a couple draw calls, which is a lot, pretty nice. All right, let's figure this out. We wanted to find the location of the player and add the player in. Add the pit in right before the player. So that sounds to me like we need to get the index up, to find the index up. If we look at our documentation, do we have a find index? I don't see anything off the top of my head. What do we have here index-wise? Partition index, that's not really helpful. Now, removes and returns the element of position index. Something we could do is remove the player and put the player back in. And that could be interesting because then we can just push everything in, remove the player, put the player back in, and then that'll be fine. But out of here, we're probably going to need to then get into an iter, and then the iter might have something that we can do. I don't see anything off the top of this. I think, this is center slice iter. We would want like a vector iter. I kind of like the idea of like bringing the player out. So like part of change screen, the first thing that we can do is maybe even like before we remove the features, we could remove the player and take that back out. We remove the feature, so remove the player, remove the features, create the features and add them in, and then add the player back in. That will guarantee that the player is always at the very end. So that might look something like this. Let player equals self dot game objects dot remove player. Maybe like even take player. What does this look like? Let's return a reference. Remove. Okay, so probably just remove. Remove player. And because we have one that's like get a reference, a mutable reference to the player. I think if we remove the player, and this is going to happen often enough that it probably needs its own. It probably can need its own just method for this. That should be fine. What do you return? You return a option, I'm guessing. Oh no, it just returns a thing. It doesn't even return an option because it's an error in case that it. Well, that's interesting. It's not even an error, is it? It's just a T. Where is T defined? Let return equals. So, okay, so. All right, exactly. All right, so it just returns the thing. Nice, nice. Then what would be next here? We want to, well, remove player. You should be yelling. Okay, yeah, I was gonna say you should be yelling at me because you don't exist yet. So let's head back over to game objects and get a test going for this. Okay, so this can be CI test move player. We know that we're going to have to create the player and the game objects. Add the player in. Okay, so game objects, push player. Once we've pushed that in, we should be able to get that out again. So we're going to do just probably a shadow here. So player equals game objects dot move player. I guess that should work here. So all right, let's implement remove player. Okay, we're going to return a game object here. Specifically a game object that has that with type or my type as a player. So we need to not retain. We need to find, does retain actually remove what got removed? No, you return a boolean. Oh, retain doesn't return anything. It just self-mutates. So I need to find the index of, and then remove that. Okay, so move. Okay, remove item. Oh, that's deprecated. Okay, so remove at positioned index. So we need to find the index of. Okay, so what is that going to look like? We need to find the index of. So let index equals self dot objects dot. I think that we're going to have to go into an iterator and then dot find. Now find returns the entire item. Oh, but can I do dot I forgot what it's called. What I want off of iterator to also get the enumerate. Okay, so if I find enumerate this find okay, yeah, we're gonna get the index and then the game object. And this is okay, this is gonna return an option of the usize game object. Okay. So then as soon as takes a closure that returns true or false, it applies. And if any of them return true, find returns some element. And it stops processing as soon as it finds the first one. Okay, perfect. So I want to return game object dot my type is equal to game types player. Okay, that then gives us our option with the usize game object. Okay, I really think this is going to have to be an option with a game object inside. Because we're getting an option here, how could I possibly return something if we don't have it? Unless I created a player. Then now that we have our index, if the index is a none, so if let some index equals index, really you're the player index. So if we don't have one, we want to just return a none. If we do have one, we want to remove. So self dot objects dot remove player index. Mismatch types. Expected. Oh, and you need to be a sum. Expected a usize. Oh, found a tuple. Right. Okay. So that because you're this. I think what I can do is destructure this out. We don't really care about the game object here, and then that should work for us. And we don't really care about you there. We only care about the game object. Okay, perfect. Then come back down to our test. We need to fix this. So you're an option game object. We want to unwrap you because we want you to never fail. And then we probably want to test something on this player to make sure it really is the player. So we can assert equal that the player dot my type is player. We also want to test that the length of the game objects is now 0. All right, do you work? It does. Okay, perfect. So then we can head back over to our main scene. When we change the screen, we remove the player, but that gives us this option. So player is like a maybe player. So this entire thing doesn't work if there's no player. Now, we should always be able to find a player. If we can't find a player, there's something horrifically wrong, and we probably should crash out to the system. Crash out. So at this point in time, we probably could just do an unwrap. That gets us a game object. Then we remove all the features. We go through here, we push in the pit, and then at the very end, we want to self.gameObjects.push the player back in. So if I do this and we rerun you, we should have a pit on the first screen and no pit on the second screen. And we should be able to move over the pit like that. Okay, perfect. But because when we move to the next screen, so here in update, if player's off screen to the right, we self player location, like reset our player location. This could probably actually happen outside of here, like inside of the change screen. Possibly. Actually, we don't know which direction we're moving, do we? We just want to, at this point, do players off screen to the right, self dot change screen, and pass it in a reference to the config. Do the same thing there. Okay, now let's try. Move over the pit. And the pit disappears as we move to the next screen. So perfect. Now, that it doesn't really look like we're moving back and forth. It just makes it look like the pit is disappearing. And that's because we also want to make the trees shift ever so slightly as soon as that happens. And this is where this images comes in. When we change screens, probably also want to pass the images in and tell the images to reset the trees. So we can head over to images. So here's our trees mesh. We have a self create trees here that gets added into the trees. So you have this create trees function. What if I then also had a reset trees? And reset trees didn't just create the trees and return the mesh. It basically called this and added that in. So we did a pub function reset trees. Okay, so this would be mute self. And I don't know if there's anything else we really need to do here. What do we need to do for our create trees? Oh, we need a context and we need a config. Right, we need a context and a config. So we do need that here. Config. We're probably going to return a game result. So we'll get the new trees and they just add it in. So this would be self dot trees equals self dot self create trees, pass into context, pass into config, and this returns the result for us. Oh, question mark that. And then we return OK. All right, so that means we need to call reset trees from our main scene. We need the context and the config. So context, bring that in here. And then this will be images dot reset trees, pass in the context, pass in the config, and question mark that. And that means in the main library for update, pass it in the context. And that makes everyone happy. So now, when I go back and forth to the screen, the tree should just shift ever so slightly. Just like light shifting, but enough to make it look like we're moving into a different zone. Now they're all shifting by the same amount, which that's not the best. It would be really nice if I could have the trees shift individually. So for images, when I create the trees, we get, the random offset happens here. I think what we need to do is do that for every loop here. And I know it's a little bit more expensive, but we're doing this inside of the update loop, which should be pretty fast. It's not going to happen in the draw loop. There we go. Okay, so now our tree positions change a little bit. Hey Chantilly, can you just shift the entire mesh? I could shift the entire mesh, but what I really wanted to do was shift like the locations of each tree just individually like this a little bit. So that makes it so we can walk through here. Okay, this is good. We've done a lot of work. Let's go ahead and like everything is working, but I want to push this. Oh, hey, welcome back, kitty cat. Do you want me to throw that? Okay, so created a pit. I can go ahead and push that up and get that started. I know, kitty cat is here. Okay, so now that we have the pit showing, I want people to fall into the pit. And this is actually something I've been a little bit worried about. Maybe before we do that, let's work on some of these warnings here. So we actually don't need obstruct heart draw system. Oh, fields are never read. But it's a struct here. I don't know if I can do anything for that at this point in time. So our heart, oh right, because we don't need these things. heart draw system is very, very basic, so maybe I won't be able to do any of these yet. That's unfortunate. Our heart draw system is drawing out all the hearts, like the heart information. But okay, you have lives here. And when I'm drawing, it's just drawing out self-thought hearts. Oh, and that's because you're a Sprite batch. So I just don't need you at all. All we have is the heart Sprite batch. We don't need you anymore. Okay, for build. Okay, so I need I needed lives. Hold on, lives is being run right here. I don't know why Dale is yelling at me. Can you see Kitty Cat properly? Sort of. Hello. Thank you for pair programming with me, Kitty Cat. He's standing on the keyboard. All right, what were we doing? We have our lives set to 3 by default. Oh, right, because we have a build that allows us to build a new lives here. So like set the lives, then build that. Set our location, set our lift. Oh, okay, so we do need all those things. Why are you yelling? My control D is okay. Why are you yelling at me? We are using those, right? Otherwise, how am I getting the hearts? In the main scene, I'm creating the hearts. Create hearts. Hearts is create hearts. Okay, so we have draw system location with type. And then we draw that out. Okay. I'm not going to worry about it right this second, but that might be something we need to figure out. All right. You can sort of see Kitty Cat. All right, so let's ignore that then for right this second. Let's do with the physics system for the player. We need to know when we pass in front of the pit. So what is that going to look like? So when our player comes over here and we're fully inside the pit and we have our width and height of the player, so we're like, we know that the left-hand side of the player is like over past the left-hand side of the pit, and the right-hand side of the player is left of the right-hand side of the pit. So we need to do that calculation. Okay. You do that calculation, and then if that's true, then we need to stop all of our horizontal velocity, and we have our player fall down into the cave. Also, I noticed that our hearts aren't showing up. So maybe we're not drawing the hearts. Let's see. Do we? Because we need the hearts are above the background. So we're creating the hearts. Why aren't you showing there? And the game objects already loops through and draws, right? So for draw, stuff to game objects. That draw, okay. So we tell them to draw. Yeah, that should work just fine. But we're not seeing the hearts. Okay, so we need to fix that. Because when we fall down the pit, we need to remove a heart. If we can zoom out the kitty cam, we can see the kitty better. Yeah, I know. I need to figure out. I have a. Let me try grabbing something up here. Let's see where it's back. I found a small tripod that I could use. It's not as best as those really tiny tripods that could, this will elevate the camera maybe a little bit too much. But let's try something like this. And I just want you not to fall. And I need to check. So here. Don't fall. I don't have the type of camera that I can screw in to the to like the tripod, so it's sort of resting on top of it. Maybe not down there. Maybe I can actually put the tripod. How about that? Well, let's see. Still too zoomed in. I need to find like a good high definition camera that allows me to maybe have like a farther away image of the camera, or like of the kitty cat, or of something else. So right now we get just a zoomed up photo, like view of him. Which is all good. All right, I'm gonna put that onto my list of things to look into. Is a better way to have my camera. Maybe like something, if I can mount the camera on a wall or something like that. That could work. Because as soon as he leaves that one platform, we're gonna have to reposition the camera. All right. So we're trying to figure out what's going on with drawing our heart. Like, why are they not drawing to the screen? And are they drawing to the screen? So here we have this hearts draw system. It's claiming that this isn't working. And here we're telling it to draw self.hearts. Self.hearts is a sprite batch, which should be... So new sprite batch with the heart image. Oh, are we not adding in? here. Okay, so here's add. To add a new Sprite budget. Are you not getting called? So in our create hearts, draw system. Oh, okay. So heart draw system new. This is our problem. We want to do new, set these, and then build. That's what we need to do. So new dot build. That should give us a basic heart. Sure Shock, hello, you redeemed Pet the Kitty Cat. We can do that. There's our hearts. There we go. I wonder, I think this is also maybe one of the things that hello, kitty cat. Oh, playful mood. Playful mood. Here you can have. Okay, so we just need to set all those things on the hearts when we're creating them to give the appropriate location, and then that will draw the hearts on the right hand side, like where we want them to go, and the right number of them, which should be 7 right now. Are you done with me? Can I go find kitty cat? I have this space behind the green screen that I think the cat will enjoy hanging out in, and that camera angle, if I like figure out the right position to put it, might be able to catch him playing. Okay, so we have the hearts there. Now what I want to do is, before build, add in all of these other things. So we have build, okay, set lives. We need the config, so we have that. So config dot player lives, then dot set location. That is, okay, so we need just an X and a Y. So that's going to be, for the X, config dot resolution X minus how wide the hearts is. So config dot lives. How do we know how wide this should be? I don't know if we know how wide you're gonna be. We could figure out your width of a single heart image and then multiply that. The cat needs its own camera crew. Absolutely. We need that. Or we need some kind of like bot, like a little robot, like a RC car that can follow the cat around with a camera on top of it. That could work for us. Maybe we can program it in Rust. So if I just do something like minus, I don't know, 250.0, and then y would be 0.0. What else do we have? Oh, set width. And then what are you in heart draw system? So width, oh, is set to 50.0. How is width used? In build. Okay. So add. So we can grab this from the image. We can grab this from the image. So we need, so to get the actual width of the image, grab this up here. So before we go build a system new, we want to do let part, or maybe like the life image width equals images.life.width. That gives us a U16 here. This needs to be a F32. Then we can use U. Okay, set location minus life image width times the number of lives. Okay. What are you upset about? Oh, dot. Okay, so set width, and this is going to be the life image width. Okay. You're F32. You're U8. So as F32. No errors anymore. Let's see if this works. There we go. There's all of our hearts. We were missing them, and that's because that's another thing that apparently I did on Friday that I forgot about. Leif me, you're learning Rust, and so far your experience has been wonderful. Awesome. I love like hearing about good Rust learning stories. It's I think it's a really fun language to learn, and I think it's been helpful in like my other programming adventures too. Or you could have several cat cameras and use AI to determine if the cat is in the camera range, and then that camera shows the cat. So basically, I can have cameras all around the room. Because like then I need to do things like this and constantly move this around so you can see the cat. It will determine which camera has the cat in it, and then go from there. Hey, Sylvie, let's try something. I'll put the cam down here again. You want this? Zilby does play fetch with us sometimes, so he may bring the ball back. He often will bring it back if he wants to continue playing fetch, and then just suddenly not ever bring it back once he's done. All right, so we have our heart. If I move over to the right, the heart should not disappear. Perfect. Okay. So then, when I come over the pit, we want to fall. So we, as the player, we need in our physics system we need in our update to know if we're over the pit. And that means we need to be able to look through all the other, okay, so we need all the features. So I need to pass in to here a vector of game objects, but they should be features. And it could be a reference to the feature. So, okay, let's add that in. That means in our game objects here, I wonder if this could be a CI test. Also, I want to update the CI test so I can like maybe change the name a little bit easier. So it's gonna be snippets, Rust. See here, I have this. I want to close you, and then do another one. Just actually keep you there. Do another one immediately, and this would be 2. Actually, it wouldn't be 2 here. We'd have test, and then 2 like that. Then we determine, hey, what is the name of this going to be? Probably something like this. So if I say view, let's see. It's definitely not how I'm used to programming, but it's a fun challenge. Yeah, I turned it off because a cat came up here. Let me move it around, repoint the cat back on again. Okay. So now I want to save you back to here. Let's redo this test. It should be a little bit easier for us. There you go. Okay, this is going to be a CI test. And then the name of the test is going to be get all features. So we want to create game objects. Well, hello. Thank you for your contribution, but I don't think that. Oh, nope. I don't think that resetting the trees 1,000 times is really all that. Ah. Okay. Pair programming time. I know. That was close with my eyes, though. That was. He's usually not gone from my face. But he did not get me. I need to undo all of you. Okay, I think we're back to a good spot. All right, so CI test get all features. We need to create the game objects. Let mute game objects. New. Okay, then I probably want to create 2 features, so I can put in I can create 2 pits. So let first pit equals we only have like 1 feature here, so create pit. We just create a pit. That'll be fine. No, not that. Okay, create pit 1. Okay, we do need a config. And we'll unwrap you. Then we'll put the pit into the game objects. Objects dot push pit. Then I want to get all game objects out, and that should be a vector. So let I expect this to be all features. I expect this to be a vec of game object equals game objects dot get all features. And I don't think I need to pass anything in because we're just saying I want to get all the features. Then I don't know if I even need to unwrap that. That's just going to give me a vector, and it'll be an empty vector if there's nothing in there. Okay, so let's make this pass. Reference itself, we're going to turn a vec of game object, and we can set mute. Do I need to make this a vector on its own right now, or can I just be a find for all? For vector here, find is, I believe, looks for everything. No, I don't want to drain. Maybe something off of the iterator would help. So we could do self dot objects dot iter dot. Let's see what we got here. So there's all that returns a boolean. Oh, if all do something. If all, or if any do something. That's not what I want. There's collect. I can filter. And okay, so I want to now filter the game object dot my type equal to game object types is a feature. Then I want to dot collect it. But this needs to know the type. Oh, and I want you to be a... There we go. Okay, so this gets all features. Let's see. Your game objects. I want you to be a reference to. Okay, so that works. Then I want to assert equal. So all features dot length is 1. And I guess that we have the pit. So assert equal all features position 0 dot my type types feature. So if I run you, passed. Okay, perfect. So then what I can do is I can get all the features and pass that in to the physics system. So that will be in here. We'll have a features, which is going to be a vec. It's going to be a vec with reference to game object. This one, however, we have to update now. So you need to be in the trait physics system. Get added in here. So far, you're the only physics system that exists, so it's a lot easier to add in. All right, so then everywhere where it's adding in a physics system, we need to add that, all the other objects. Okay, so update. I think what's easiest to do here, go to the end. So there's some, and this can be an empty vec. Then in game objects, okay, this is where if we have a physics system, then we want to grab out, so let features equals self dot this is and game objects. Self dot get. Come on. Where did I put it? Oh, this isn't game object. Okay, hold on. We're gonna have features added in here. Throw you in here. Then in here, where we call update, we have these get all features. We can grab you from here. In fact, we should just be able to call this right here. So self dot get all features. Like that. Cannot borrow self is immutable. Oh, okay. We can't actually do that here. We did it up here. That features equals self dot features. And features. Cannot borrow self objects is mutable because also borrowed is immutable. Right. Okay. So features is a reference to these objects. I might need to clone them. I might need to clone them. We can do a very light clone. That might work out. I need to think about how I want to do that clone. So I think I'm going to take a really quick break because it's been about an hour and a half, maybe a little bit less. I'm going to go grab some more water. I turn off cat cam because cat's not here. Grab some more water, think about this, and I'll be right back. So head over to, I don't have a break screen on here. Okay, never mind. I will do this manually. Break screen. I will be right back.